Okay, so let's assume you time travel back to 1622 and you're in pre-colonial America, probably somewhere near Jamestown, and for some reason you're still holding a baseball that you had in your hand for some reason. And in the distance you see a pilgrim, and he asks you, what's that in your hand? And it's a baseball. Would you like to see it? You say. So you throw it over to him, but we're going to analyze the path and the motion that the baseball would take as it leaves your hand and goes over to the pilgrim. So when you throw the ball, it's going to follow a path somewhat like this, more or less. So as you can see, it's an arch, but it's essentially a parabola in shape. So we're going to analyze the ball at different locations along its path. So first we'll have here just after it leaves your hand, here as it goes higher up, here where it's at its highest point, and another one on the way down, and finally just before it reaches the pilgrim's hand. So what we know about the velocity of the ball as it goes through the air, and we're going to be ignoring air resistance for this. So what we know about the velocity, this is an example of two-dimensional motion, meaning that the ball is not only traveling in one direction, it's traveling in two. So it's traveling upwards as well as right to left, left to right. So there's two different types, or two velocities that we need to look at here. So we're going to be using velocity vectors to quantify those, or qualitatively look at them. So in terms of the x, or horizontal velocity, it is going to remain the same for the ball at all locations. And we know this because the forces acting on the ball are equal horizontally. There is no force as the ball travels through the air. No forces are acting on it horizontally, so therefore there are no changes in its horizontal velocity. But in terms of vertical velocity, it is not balanced because of the force of gravity. So we can measure that. Another vector here, and as it goes up, it gets smaller. Let's see. As it goes up into the air, because of the force of gravity, it is going to get smaller. And likewise, on the way down, it will increase due to the force of gravity. So if we were to look at the vectors, we would be able to see the exact direction of the velocity of the ball as it travels through the air. So like that. But the interesting part is, as it reaches the top of as the ball reaches the top of the arch, there is no vertical velocity. Therefore, the ball just stays in that one space instantaneously. Therefore, it just stays there. But on the way down, it comes back like this. So how do we know that the ball does not have balanced forces up and down? Well, like I said, that's because of the force of gravity, which remains the same throughout the pathway of the ball, no matter where it is, be it closer or farther away from the ground. So, in order to further impress these pilgrims, you decide to go back to 2017, grab a basic circuit, some wires, a light bulb, and a battery, and go back, except this time you're in 1623. So you show the pilgrims the circuit setup, and you tell them, I will show you how to light up this light bulb like a candle, except with no fire. And they don't believe you, so in order to convince them, you decide to connect the circuit. And so once you connect the circuit, all of a sudden the light bulb starts glowing. And of course they're amazed, but they ask, how is this possible? So you explain to them, from the battery there is a source of potential difference, which is essentially like charge elevation. You explain to them, and one end of the battery is negative and the other is positive, and you explain that charges have the tendency to want to go from a high elevation to a low elevation. So there are charges, being a fundamental characteristic of any real, surface. There's a lot of charge in the wire, but it's not moving. So in order to get it moving and create a current, there's you connect it to a battery. So since charges want to move from low potential to high, from high potential to low potential, they follow a current path like this. And as the charges flow through the filament in the battery, the energy causes it to light up. Therefore, when you disconnect it, there is no more, the circuit is not completed, therefore there won't be the charges can't go the full cycle and go through the battery and light up. But when there is, because of the electric potential from the battery, that causes it to light up and stun the pilgrims.